setup, we're going to check to make sure that the axis is moving in the right directions, and up and down, and then the E-stop works. So there's two ways to jog. One is to just press buttons. Left, right, up, down.
Hey guys, it's Vince. Today in this video, we're checking out the channel I Build This. It's got 344 subscribers. It's got supposedly 64 likes that are coming from humans. Let's see if he can build us a tutorial on how to calibrate and set up our new 6090 CNC.
We're going to select native units, press OK, and we're going to make sure it's inches. When you open Mach 3, you're going to see, well, this screen. You just got your system, and the first thing you're going to do is try to press some buttons, and nothing's going to work. If you have the USB CNC, you're going to navigate.
There's our first mistake. I've discussed this in probably at least 100 plus videos. This board seems to be the one of preferred use between many end users because it's extremely cheap. You see it's listed here for 35 bucks. You go on AliExpress, get this thing for like $7. And the thing to keep in mind is universal serial bus for CNC robotics is completely unstable. I will put the evidence up here. It's got grounding issues, voltage spikes, susceptibility. We also deal with lots and lots of EMI susceptibility because again, it is very low voltage. You guys, if you expect a stable robot, stay with Ethernet or parallel port. Get away from this.
Yep.
So we're going to come over here. This, of course, is port and pin configuration for his axis to make sure that Mach is communicating properly with that USB controller. I want you to listen to this.
Direction's 3, Y is 4, direction 5, Z is 6, and direction is 7. And that's all you have to worry about this one. If one of your axes is going in the wrong direction, then you're going to change the direction low right here. So say your X is going.
So if your axis is going in the wrong direction, you would change your direction low. No. Why would you do that, sir? Mach 3 has a feature for reversing an axis. If you're an authority and you understand Mach 3, you should understand that that's already there and the end user should be using that instead of direction low. And why is that? Because if the end user uses direction low instead of the reversing option for that axis, if your controller requires direction low to be active, you will not be able to do that because you've already done that now with what you've already explained. So once again, stay with the feature set that's embedded in Mach 3 first. Don't look for workarounds around that. Do your research. This gentleman obviously didn't.
Steps at 8.
So right here, he's going to input set steps per velocity and acceleration. Now, the thing to keep in mind, guys, as he does this.
129, the velocity at 100, and the acceleration at 50.
The problem is that many guys feel that plugging these numbers in from whatever a manufacturer gives them instantly gives them a calibrated machine. No. Why is that? Because we have a robot, and we have a robot that's assembled with multiple components, with multiple variables, and those variables mainly consist of inconsistencies when manufacturing because nothing is 100% accurate when it's machined, and therefore when you bolt that contraption together, what you find is that there are tolerances, and those tolerances, positive or negative, are going to add up cumulatively. And as you have motion, regardless of open loop stepper, closed loop stepper, whatever your automation system is, you are going to have those variables compounded, and until you actually run a set steps per module in Mach 3 to do precision calibration as seen on screen here by ex-client James, you will not take into account those variables, and therefore you will not have a properly calibrated robot. If you don't believe what I'm saying, you're more than welcome to confer with AI. I'm telling you right now, everything I've just stated is fact. Do not believe for a minute anywhere from anyone that all you do is plug numbers in and instantly you have a calibrated robot. The other thing to keep in mind, and I see this done frequently, is guys instantly adjust their velocity and acceleration. The thing to keep in mind here is these are a baseline setting for your speed on your axis. These numbers should be set at the absolute minimum for movement until you properly calibrate with set steps per axis. And the reason we do that is because speed comes after accuracy. Who gives a rat's ass how fast your robot is if it's not accurate?
If you have a manual, you were lucky enough to get a manual with your machine, follow what they've done and don't listen to what I'm saying, but we're going to press the save axis. We're going to go to Y and up and down.
Now we're going to come over here and listen to this gentleman explain how to set up your axis. And he's going to explain how he's jogging them. So what you're going to listen to, I want you to listen closely to, because remember, this is a tutorial, right?
Down, and then the E-stop works. So there's two ways to jog. One is to just press buttons. Left, right, up, down.
Did you hear that? Oh my God. Did you hear what he just said? Let's play it again.
Down, and then the E-stop works. So there's two ways to jog. One is to just press buttons. Left, right, up, down.
So those that don't know, let me make you aware. He said left, right, the Y-axis move. He said up, down on the keyboard and his X-axis move. So let's get this straight. Left and right on your keyboard, as far as your arrow keys, represent the Y-axis? No, sir, that's incorrect. Left and right represent your X-axis. You had it backwards. So therefore, once again, we have misinformation being dispersed by a content creator who is obviously a novice at not only creating content, but also performing research dictated by what I'm showing you here on screen as direct evidence. This is direct misinformation, once again, being spread. Now that we know this, where do you think this goes from here? I'm wondering what you guys think is going to happen here. I mean, he's already directed his audience, who already gave him supposedly 64 likes, of how to move his axis incorrectly. He's not even aware of the correct correlation in axis movement on his robot. Think about it.
And then I'm on a laptop, so function up and down. But really it's page up and page down. And now we're going to make sure that the E-stop works.
Let's talk logically here, okay? We're all on the same page here, I think. Why in the hell would you check your E-stop after movement? Would you get in a car you just built that you never drove, you have no idea if this thing runs, and not check the brakes first? Makes sense? Always test your E-stop first. That's your emergency stop. And that makes sure that any particular movement can be instantly halted. If you don't do that, and you start jogging like that, and you don't know what you're doing and continue to hold the key, you can instantly crash the machine, especially if soft limits are not set up. So, or switches for that matter, because you didn't do that either. So keep in mind what I'm saying. Logic comes with experience. And when you start thinking about what you're seeing here, you're seeing the definition of inexperience.
Drag this over a little bit. I'm just going to jog it and then press the E-stop. All right. So there we are good to go. Now that we have our CNC set up in Mach 3.
No, sir. What you actually have is the port and pin configuration so that the axes are communicating correctly with Mach 3, and you have your E-stop configured in Mach 3. Details count. You did not set Mach 3 up yet. As a matter of fact, we didn't see any switches if your machine has them, which I believe it does because I see one right over here. I'm telling you right now, guys, be concise with details. What you're seeing here is a guy running through what he feels is a tutorial. This is not a tutorial. You'll see exactly what I'm saying as we continue.
What we're going to do is when we tell it to run inch, we want to make sure that it runs 1 inch. We're going to do that with a pair of calipers, and I'll leave a link for the pair that I have in the description.
Don't you love how a content creator is always willing to sacrifice his time and effort to give you a link to the incorrect tool to use to calibrate your robot? Like, what the fuck? Like, are you telling me seriously, sir, you had time to make a link, but you couldn't actually refer to any type of documentation, any type of AI, any type of Google search to make sure that the tool you're using is accurate for what you're working with? This is why I tell you guys, be very careful.
Started. We're going to head up here and click on MDI, which is manual data input. And from here, we'll be able to put in some programming so we can control it immediately. With the motor off.
Hey guys, jump over to eDealers Direct Automation and check out my eBay store for the components used to make what you see in this video, as well as many others that you may not even realize you need. Of course, I'm always there if you have questions. Message me and I'll get back to you as soon as possible. And of course, I do custom engineering as well as consultations. Thank you for watching this video and your support. Take care.
we are going to get the spindle into a nice, easy location. So right now we are reading.
Doesn't it piss you off when you see guys use high quality tools like this Starrett caliper here incorrectly?
About 0.8. We were going to bring this to 1 inch, and we can just do that with the dial. I'm actually going to bring it out a little bit.
Guys, this is an open loop system. If you move the motors by hand, for reference, just to let you know, now he's doing calibration. Technically, you can get away with this because he's doing calibration, but he never explains to his audience, you never want to move an open loop motor manually, because once you do, Mach 3 loses its position. This is the whole premise of an open loop system, pending, of course, you understand it. What we've seen just right here would have screwed up a system had it been in calibration, and him not make his audience aware that moving a motor manually that is open loop will in fact create you to actually go through this process all over again.
There we go. And then I can bring it back.
It is absolutely impossible for anyone to hold a caliper perfectly perpendicular and parallel to an axis being measured. The whole idea of calibration is accuracy. That's why you use a precision measuring instrument like a test dial indicator or a dial indicator with a high accuracy, meaning usually 5/10,000ths of an inch or even lower than that, 1 to 2/10,000ths of an inch. Yes, they cost more money. The whole point of owning a robot is so you have an accurate machine for production. What you're doing right here, sir, is butchering the entire process of owning a robot, in that you are never going to formulate any type of accuracy using this method. This is complete misinformation. Watch James right here. You'll see he's using gauge blocks. He's using the dial indicator. That is the proper way to do this, because once again, the dial indicator is mounted stably horizontally to the axis so that we get repetitious, consistent results.
So it reads 1 inch. There we go. Perfect. We're going to 0 our Y. That's what we'll work on first. We want to do G0, and then we're going to do Y1. And we'll check the measurement again.
Guys always tell me you don't believe it until you see it.
Then we have 2 inches.
We have 2 inches? Where do you see a whole number there, sir? 2 inches would be a whole 0, meaning this needle right here would be at the 0. What we see here is this caliper is 1,000th, I believe, of an inch accuracy. So if you actually knew how to read this, he's 1, 2, 3, 4, 5,000ths over an even number. Okay, so keep that in mind, guys. This is why I tell you guys, be careful who you learn from. This is fact. You can research this. This guy doesn't even understand a whole number reading on his Starrett caliper. He's telling you this is an even number. The only way it would be an even number is the end user would start at zeroing the gauge and then moving from there to take a measurement. This is fact. Anyone will tell you that. What we're seeing here is a blatant disregard for the process. And again, this is why you have to be careful.
We'll do it one more time. This time we're going to do Y2. And that'll go to 2. And this time it should read 3 inches since we started off at 1 inch.
What the fuck? There you go. Off again. He's telling you it's an even number, it's off. Okay? So this is why I'm telling you guys, be careful. Here's another thought. If you have problems with analog gauges like we see here, the Starrett is still a great caliper. You just have to understand what you're reading. This is nowhere near as easy to read as a digital indicator. And you'll pay more for a digital indicator because it's convenient, because it just reads the numbers out in LED fashion. Very easy for a novice, or anyone for that matter, to look at that and understand, okay, this is where I'm at exactly. This is, once again, analog. So it's only as good as the interpretation of the end user using it.
3 inches.
When, of course, they're using it for the right application, in which case this is not.
So we're good with the first position. Now we can check the x-axis. So to do...
Did you hear what he just said? Let's do that again.
With the first position. Now we can check the x-axis.
He doesn't even know which axis he's calibrating. This is the x-axis. We'll put it on screen again. I hope he watches this video because at least then he learns from what he's putting up. He's getting views. Once again, in 8 months, he got 2,000 views, which essentially he's stealing from YouTube, because if he's dispersing misinformation, does he deserve the views? That's interesting. It's a good question. It's a very, very moral compass type question. You're getting views based on information you're putting out that's not even accurate. Interesting.
So to do that, we're going to jog with just the arrow keys all the way to the edge. I'm going to turn it off again, and we are at 1 inch exactly.
Now guys, when you're jogging all the way to the edge like he just did, go into your motor tuning settings, turn it way down. That's the best way to do it, especially if you're novice. You can do it through the MPEG adjustment in Mach 3 if you want to do it that way. But overall, the easiest way to do it to make sure there's no headaches, go into Mach 3 under motor tuning, and once again, adjust your acceleration and velocity settings as low as possible. Go to like 20. It'll take longer for the axis to get to the edge, but guess what? You have much finer control, and therefore you will not make contact with the axis stops, because that creates more problems on the machine. I see this done continuously, and once again, it's really like fingernails going on a chalkboard when we don't use logic and think about what we're actually doing. When you make contact with the end stop, even if it's minor contact, you're putting excess stress on your chassis. This is considered not best practice, and therefore that's why I'm bringing it to your attention.
Well, 0, and just do x minus 1, since we're going in the negative direction. And this should read
Unbelievable.
2. And it does. So I'm happy with that. Now finally,
Now of course he didn't show you the reading because we would have identified that it's probably not correct anyways.
we are going to check the z distance. So we will 0 the z. It is at 1 inch, and then we'll tell it to travel 1 inch in the negative direction. So we'll just do z minus 1. And we will check it again. And we are at basically 2 inches.
And you could see as he's holding this unit, once again, his hand is wiggling. This isn't perfectly perpendicular. I mean, this is ridiculous.
I'm very happy with that. So that is done. Now,
I'm asking all of you again, and even the ones that get butthurt because of my videos where they think I'm not so nice. Is it that I'm not so nice, or you just hate the person the most that tells the truth? That could be. What if a guy that built your machine used his information to calibrate it and then gave it to you?
if for some reason your steps are not correctly programmed, there's a simple equation to be able to help. So the way you calculate it is...
What the fuck is he talking about? All you have to do, and do it correctly, is go into the set steps per calculator built into Mach 3, showing you on screen here. Once again, we do not rely on manual math anymore. This isn't 1962, sir. We need to do things correctly. And there's no manual math that's going to correct for, once again, built-in variables that are due to tolerance levels when machining is done. This is why pretending to be something you're not becomes embarrassing when people are watching that do understand the process.
The steps that you want to put into the program are the current steps that you have in Mach 3 times the program distance. So if you wanted to go, if you told it to go 1 inch, that would be the number you put up here. And then the distance traveled would be the measured distance. So if it only traveled 0.8 inches, then you would do your current steps times 1 inch divided by 0.8 inches, and you will have a very close...
Oh, what are we going to have? Wait a minute. What are we going to have? Say it again.
8 inches, and you will have a very close...
Very close? And for all the guys out there that get butthurt because they say you're too technical, I'm a woodworker, I'm a hobbyist, whatever terminology you want to use, let me tell you what I am. I'm the guy you come to when you've tried all these videos and they don't work. I'm that guy. I'm that guy that when he builds the system, he builds it like he would expect to receive. And you know what? That's why you come to me. You may use my channel when you find that everyone else is telling you bullshit and you want the truth. That's when you find me. So keep that in mind as you go through videos like this, and be honest with yourself before leaving a negative comment or saying something snarky.
New steps to put in there. At this point, your CNC should be moving and you should be ready for your first cuts.
If you follow this gentleman's tutorial and you think now your machine is moving and ready for its first cuts, you are sadly mistaken. He did not cover anything dealing with the variables and intolerances that I've discussed, and of course those thousands, maybe less than a thousandth, how it compounds over the length of each axis as we find those discrepancies and we don't account for them. Meaning that maybe it's only off by a thousandth of an inch moving every 3 inches, or 2/1000ths of an inch moving every 2 inches, but that variable is multiplied over the length of whatever axis you're performing calibration on. That's why understanding engineering is not an easy thing. And that's why engineers make more money, because they make money based on the problems they solve. If you're readily available and there's a million people like you, guess what? You're going to get paid that way. If you're not and you're a specialist, well, guess what? You're going to get paid that way. What you just saw here, I'll let you decide. Is he a specialist?